Okay, yeah, thank you for everyone for coming and being here. I'm really excited today to talk to everyone about our product, Coronata. Okay, first, let's discuss the motivation behind our product, Coronata. Let me first define open source projects. Open source projects are software projects whose source code is publicly available for anyone to use, modify, or share. Anyone in the world can join these projects, and many large enterprise systems contain many open source projects. Open source projects are thus experiencing rapid growth in our world as we rely more and more on these open source projects. The risk of vulnerabilities and attacks from malicious actors is constantly increasing. Ensuring the security and integrity of these open source projects is therefore critical. Coronata uniquely monitors the social interactions of these open source projects as compared to other methods. As you can see here on the slide, here is a popular meme online about the issue where you have a really large code base that might rely on a random small project that a single maintainer is maintaining. Coronata can help solve this problem by monitoring these projects. And as you can see, if one of these small open source projects gets attacked, it could tumble the entire code base. Okay. Coronata uses several different metrics to monitor open source projects. Today, we will solely be focusing on our topic analysis metric, which I'll discuss more in this slide and in consequential slides. At a very high level, this topic analysis metric can allow us to monitor changes in social interactions by tracking topics being discussed in pull requests and issues inside open source projects. We also developed a flag to alert if cybersecurity or negative sentiment discussions are being discussed inside these open source repos. And we created a visual tool to allow users to deep dive into repo topics over time to gain analysis. And in addition, have a way to add a scoring system to these repos for potential attacks in the future. Okay. Our Coronata project as a whole can be used in several different use cases. For one, alerting for cyber attack discussions within open source repos. Coronata tries to alert users of these attacks quickly and before they are discussed widely online or in major news articles. Time is obviously very crucial in these situations, and our goal is to get to the left of these cyber attacks before they can cause serious damage. Number two, alerting for anomalous patterns of behavior. Our project can help determine if a user becomes a single contributor and could potentially lead to them inserting malicious code into an open source repo. This method actually took place pretty recently in the XZ open source repo, where a foreign adversary became the main contributor and added a backdoor attack code to the XZ repo. XZ was a very small open source repo, but was widely used. Over the course of several years, the user slowly became one of the sole contributors and maintainer of that project. That is when they added the backdoor attack code, which was luckily found by a Microsoft engineer before it caused serious damage. And lastly, we can create a rating system for open source repos to see if a repo is worth adding to a code base, or if the rating falls over time, you can maybe take that out of the code base. Okay, so that is the background of Coronata and our potential use cases. I would like now to discuss specifically our topic analysis metric, which I'll be discussing in this presentation. Our topic analysis metric is based on methods in the field of topic modeling, which is a subfield inside machine learning. A quick definition and background of topic modeling is that it is an unsupervised machine learning technique to discover high-level topics within a large collection of text data. So basically, you have a large collection of text data, and you want to be able to find out what is being discussed inside this data. I won't go into too much detail on all the different types of topic modeling methods, but basically they follow the general pipeline of turning documents into vectors, clustering those documents, and identifying clusters of keywords to represent high-level topics. Okay, so there are many different topic modeling models that we have experimented with in the past, like LDA, some other methods. but we found the best results using BERTopic. It seems to minimize noise the best and empirically gives the best topic results we have found. I guess to go over BERTopic, BERTopic basically uses a transformer-based embedding layer from the BERT transformer model. It then uses several clustering algorithms as seen here to convert text into coherent topics. Basically, BERTopic represents each topic as a vector in the embedding space, groups similar documents together, and extracts representative keywords for each of the topics. As you can see in the graph, these are the specific algorithms that are used. UMAP for dimension reduction, HDB scan for clustering, and the TF-IDF matrix to measure word importance, and that's where the keywords are found from. Okay. Next, let's discuss our adaptation of BERTopic. For one, we are modifying the data, the input data into the BERTopic model. We are running it through a custom pre-processing step to take out unwanted text from our data set, things like web links, usernames, different things like that that don't add value to the topics being discussed. Then the data is organized into month-long segments by each open source repo. And then second, we refine how BERTopic labels topics to highlight specifically cybersecurity terms and negative sentiment. Inside BERTopic, we are modifying the TF-IDF matrix, as I showed in the previous slide, which is used to cluster and find important keywords of the topic. More specifically, what we're adding to the BERTopic model is a customizable cyber term dictionary that users can add cyber words to or take some out that aren't as interesting. We are also adding in a sentiment analysis model to label the input data as positive, negative, neutral. And then we combine those two to modify the weightings of the keywords inside the TF-IDF matrix to identify better topics surrounding cybersecurity and negative sentiment. Okay, here's a quick slide going over the system flow of Coronata for topic analysis. Number one, we input the social data from open source repos. Here's an example of a GitHub comment that we would input into our system. We run that through a custom pre-processing step. We apply that to our adapted BERTopic model, and then we output these topics in month-long segments for each of the open source repos. Okay. Okay. Okay, so here's a quick demo of our product. As you can see here, hopefully it's okay to see, but each one of these bars inside the graph represents a month-long time span inside a repo, inside one open source repo. The x-axis represents the length of time for this repo. I forget the exact name of the repo I'm displaying, but the leftmost is when the repo started. The rightmost is our last scraped data. So the y-axis represents how many topics are being discussed inside each month-long chunk. So just a quick thing you can observe from this chart already that a lot more topics are being discussed inside this middle portion of the repo. So as you see here, I just clicked on one of the month-long chunks. And then you can scroll down here and display all of the different topics being discussed that the BERTopic model found. It's displaying the top 10 keywords associated with the topic. The number represents how many comments are associated with each of the topics. And then lastly, that's just the sentiment score of all the comments, positive, negative, and red is, positive, neutral, and red is negative. And then we just have a filter here that just displays only the cybersecurity topics being discussed. It uses that customizable dictionary I talked about. And yeah, these topics are discussing a CVE, a security topic. This one also is discussing a cyber related topic. And then this one's also discussing a CVE. And then if you click the comment button, it pulls up all the comments associated with that topic. You can see the text, the author, the published date, the probability, the PR number, and also the sentiment score for each comment. And then lastly, we added a feature to see or to kind of see how topics could potentially have evolved over time. So once you click this button, it pulls up the previous years of keywords, and then for each month, it correlates the base keywords to the highest correlation in the previous months. So you can kind of see how topics could have potentially evolved over time. And you can click on one of these here just to pull up a similar or the highest correlated topic being discussed. And as you can see, this one's kind of similar to the original one, and it seems like it's trying to fix a security bug fix. And then lastly, you can click this button to pull up the comments associated with that new keyword. Okay. See. Okay. Okay. Okay, yeah. Lastly, I would like to compare empirically the original BERTopic model as compared to our adaptation of it. To do so, I'll briefly go over how to read one of this topic word score metric. A topic word score metric shows how strongly each keyword relates to associated high-level topic. A higher score means it relates more. A lower score means it relates less. As you can see in this topic one, design has the highest correlation, around like a 0.5. So that correlates more to this higher level topic being discussed. And these are just all the top keywords associated with each of the higher level topics. Okay. Okay, to compare the two methods, I ran the same month-long segment into both the original BERTopic and Coronada's method. And as you can see, just empirically, Coronada gives much better results. For example, you can see in topic one, it's talking about a bug fix, a merge, a release, things like that. So you could deep dive into that further, and it should make the comment should correlate and make like a lot of sense. And also you can see that the probability associated with those topics is much higher than the original BERTopic model. And as you can see, the probabilities are a lot less, and it's a lot more it has a lot more noise and other things like that. We would like to in the future add a better metric to compare different topic models with one another. But as for now, we're just empirically comparing the models, and Coronada gives much better results compared to other topic models. Okay, here's a slide going over future work and future improvement that we would like to do. For number one, we would like to add LLM summarization instead of just listing the keywords. Here's two papers that claim to do so. We really want to add this because it'll just explain a lot better about what the topics are being discussed, especially if someone doesn't know all of the code words and things like that being discussed in open source repos. Number two, we want to track topic mutations better over time. We want to improve how the graph looked and achieve better results, and do more of a deep dive to show and prove that topics are being mutated over time. And then lastly, we have other metrics in our system that we would like to combine with topic analysis, maybe do a chaining mechanism or different things like that, just to achieve a better output and better results. Okay. So yes, in conclusion, for one, we enable the automatic detection and flagging of topics surrounding cybersecurity words. Number two, we structure the insights of social interactions and open source repos to be monitored. And number three, we outperform older topic modeling methods like LDA, the original adaptation of BERTopic, and other topic models. And then lastly, we are on Platform One Marketplace. If anyone has access to that, you can definitely find us there if you want to learn more. And yeah, thank you everyone so much. Yeah, here's a way to contact us, and I'd be happy to answer any questions.
So I apologize if I missed this, but you spent a while talking about how the topic modeling that you did gave you at least qualitatively better results over BERT, but I never saw any like technical details about what it is you changed between BERT and your topic model, or how you evaluated it more than just sort of the final eye chart bar graph.
Yeah, I guess to answer that, basically we're modifying the TF IDF matrix inside BERTopic, and that basically weights the different associated
Yeah, how?
keywords.
Modifying it, that doesn't.
Yeah, okay, sorry.
Technical, like,
Yeah, basically we like double the score if like if a keyword is found that has like negative sentiment, or if it's one of those cybersecurity words inside of our dictionary, we basically double the value and inflate the artificially inflate the occurrence of that keyword to show it better.
So that's the big technical innovation.
Yeah.
Is you reweighted some term frequencies.
Yeah.
Based on topical.
Yeah.
Okay, thanks.
Hi, so can you connect your findings here in terms of topic modeling back to the original goal you were talking about in terms of being able to identify malicious factors, potentially pushing vulnerabilities or code?
Yeah. Sorry, could you say that one more time?
Yeah, so initially in the beginning, my understanding was that the ultimate goal here to like understand malicious actors or like pushing vulnerabilities or things along those lines. Maybe I misunderstood, but can you connect back your conclusions here or your findings in terms of being able to do topic modeling back to that subject?
Oh, I see. Yeah, I guess we haven't correlated it back to that. I guess we just want just to be able to alert if topics are being discussed. I guess we're still in the research and proving phase of this, but yeah, I guess that would be a goal to apply this to actual more real world examples and kind of show that we can predict that. So.
Thank you for the talk. I had a question. How do you see keyword extraction or some of those nature? Because topic modeling would have, I guess, assisted with understanding, but do you think keyword extraction also might have been something which would be useful here, or is topic, like, was the hierarchy of the topics to BERTopic more helpful in some way?
Yeah, I guess could you rephrase that?
Yeah, do you think keyword extraction would be equally viable as an alternative?
Yeah, I guess I see what you're saying. Yeah, I guess we could do that. But yeah, I guess just maybe we're more or less finding like the context, I guess, of the keywords, and maybe we're finding more nuance, I guess. But I guess that would be a good comparison to just to maybe prove that ours is doing that versus a keyword search. So.
Great, thank you so much. Here, another round of applause for Chris.